Hey everybody, this is the toolkit for Unit 5, Lesson 1, Investigation 1, Functions and Function Notation. So let's start with what the function notation. So we write this f parentheses x. And how we say this is we say it when we read this, we say f of x, or sometimes we say f is a function of x. And that's really what all of this means, or that's what that notation means. And if we wanted to write it out, we could say for every x value, which is our independent variable, but so for every x value, there is exactly one y value, which is our dependent variable. So what that means is that when we have an x, there can only be one y associated with that. We can't have multiple values of y associated with one x. So, what we could say is that f depends on x, which is kind of like y depends on x. The dependent variable depends on the independent variable. But that's really what it boils down to. So let's look at this graphically so we can see what this looks like. If we had, let's say, a graph that looked like this, kind of a curve, or maybe we had a series of points, or maybe we even had a parabola. All of these things would be considered functions, because as we go across the x, we can see that there's only one y value for each x, and we could do this for all of them. Now, even though here there is the y value is repeated, when you look at the x value, there's only one y value associated with that x. So that y value may be repeated with different x values, but that individual x does not have two different y values associated with it. Excuse me. So let's look at a couple others. So maybe we had a sideways parabola, or we have a series of dots that look like this, or a series of points. These are not functions, because now we can truly see that for this value of x, there's two values for y. And similarly, on this one, we've got two values of y shown here. So, and even here, we've got four values of y for one x. So these things are not functions. Okay? So let's look at this as if we were looking at a table, or numerically. So if we put together a table, let's say we have values 1, 2, 3, 4, and 1. And then we have 4, -1, 0, 10, and 4. Now the first thing you should look at is, hey, I've got two x's here. I've got two x's repeated. The 1 is repeated. But if you notice, the y is the same for each one. It's both a positive 4. So x still has the same y. It only has one y value. So this is a function. What if we had x and y's? We had 1, 2, 3, 4, 1 again, and now we had 4, -1, 0, 10, and 5. So again, we've got our x's. This 1 is repeated, but now notice that there's two different y values here for the value of 1. So 1x has two different values of y. So this is not a function, not a function. And lastly, for our numerical examples, let's look at this. Let's say we got 1, 2, 3, 4, and 4, -1, 0, 4. Okay, so now again, we've got this 4 repeated, but if you notice, we don't have any of our x's repeated with different y values. So all of our x's are the same, or all the x's are listed. They all have different y values for each one. So this is a function. Each x has one y value, so we will call this a function as well. This would be kind of like our parabola, the one in the middle, this function right here. So that might be like that one. Right, so let's look at some definitions now. So if we want to talk about, the other thing that we talk about with functions and functions notation is domain and range. So let's start with domain. Domain is all of the possible x values for a function. Every single possible x value. And remember, this is our independent variable, right? So that's the one that always goes across the x-axis, it's x values. And the range is all the possible y values for a function. right? So pretty straightforward. Domain is x, range is y. Remember that y is our dependent variable. So if you're looking at something in context, you can look at it with independent or dependent. If you're looking at it graphically, you can look at it as x and y. But that's our domain and range. And when we state what our domain and range is, or when we're talking about them, we generally either list them, we list out all the values, or we state what the options are, what the possible values are for that domain or for that range. So let's look at an example. Let's say we've got a downward facing parabola and the maximum value is at 3. So if we talk about our domain, this parabola goes on in both directions, so as we get bigger with x and as we get infinitely smaller with x, we're going to keep on getting values of y. So our domain is going to be all real numbers for x. So every possible x value we could come up with, there will be a y value. Now when we look at the range though, if you notice that the top of the parabola is at 3, at 0, 3. So it doesn't get any bigger than that. So we could say that y is less than or equal to 3 for our range. So our domain and range don't always match up, but you have to look at them individually as you're sorting out what is your domain and what is your range. Let's look at a table of values. Let's say we've got 1, 3, 5, 8, and 9, and then we have 4, 2, 5, 3, and 6. So if we want to state our domain for this, we could just list out our values. So we put in this little brace and we say 1, 3, 5, 8, 9. And our range, we're going to put again the little braces there, the little squiggly parentheses, and we'll have 2, 3, 4, 5, 6. Now notice you don't necessarily have to pair them up, the 1 with the 4, the 3 with the 2. You just put them in numerical order. You can say, here are all the numbers for my domain. I don't care which ones they pair up with, but these are the numbers in my domain, and here are the numbers with my range. So I'm just going to list those out as well. So it's nice to see them in numerical order, but you don't necessarily have to put them in that way. Now the last thing that we talk about with our domain and range is theoretical domain and range versus practical domain and range. Theoretical is all the mathematically possible outcomes or values for your domain or range. And really when you look at this, we call it naked math sometimes, but there is no context. There's no words to the problem. It's just a straight up problem, and you're just trying to find all the values that you could plug into the equation and all the values that you would get out. And your practical domain and range are going to be contextually based. So it's contextually possible values for your x and y. Maybe if you're talking about how fast a car goes and the stopping distance, theoretically if we had an equation we could put any number in for how fast a car is going, but practically you're going to have a limit on how fast a kind could go. So your contextual or your practical domain and range is going to be smaller than your theoretical. So I hope that helps kind of clarify functions and function notation, domain and range, and I will talk to you for the next toolkit.